Hello guys, welcome back to another tutorial. Hit the bell icon button so that you don't miss out any tutorial.
In this lesson, we're going to continue discussing classes and objects and how to write programs with them, and we'll take a look at how they can be helpful in organizing and designing our programs. We're going to take a look at some of the more advanced concepts in what we refer to as object-oriented programming. That is, the programming that heavily involves classes and objects and sort of interactions between them, and how we can apply some of these advanced concepts in our programs. We'll look at things like inheritance and method overloading. So let's get started and explain what those things are. So we've been looking at classes for a while, and by now I think we have an understanding that we can use classes as a way to kind of hold a set of information and actions that we can use to describe a particular object. And usually we use that to kind of represent some object within our program. We've been using examples with cars, but there's a lot of other applications. In any kind of program that you'd want to write, you can kind of use classes and objects to sort of model the information that someone is passing into your program and store it and kind of keep it related in a way that makes a lot of sense and is easy to understand. So we're going to talk about this concept of inheritance, and inheritance is a way for classes to get sort of new attributes and methods from other classes. When you create a class, you have what's called the ability to specify a class that it inherits from, and we call that class its parent class. So in the parent class, you can define some attributes and methods like you would on any other class, and then you inherit from that class in a child class, and the child class gets all the methods and attributes of the parent class. So we'll really quickly take a look at a simple example. Here in the code you can see in the last lesson we were looking at examples of a car class, and the code that we have on the right hand side inherits from that car class, so it still has methods from the car class even though we haven't defined them. So let's take a look at running some code like this and making sure it works appropriately. Alright, so to get started working with inheritance, we're going to actually open one of the older car programs that we worked on before. So we previously had a class car that defined some methods and some instance attributes, things that were specific to the object. So let's see how we can inherit from this class. Generally, the way we use inheritance is we can have something that's a base class, and then we use a more specific class to kind of add some additional information. So our base class might be car in this case, and then we'll have a specific kind of car that is our more specific class, and we inherit the base functionality of car. So I'm going to remove these instance variables. And I'm going to create a new class. And just like that, that's the way that we specify that our class is inheriting from the base car class. So just as is, this class will have all of the methods and variables that a regular car does. And we can actually do this by creating an empty class, and we can do that like this. So on the next line, instead of writing any functions or anything, or just do an indent and pass. And this basically is telling Python, don't do anything here. You can actually use pass in functions in a couple different places. Any place you have blocks like this, where you indent, you can pass, and that's basically saying, don't do anything. So now let's load this into the Python 3 interpreter and see what happens when we create an instance, or rather an object, of this Honda Civic. So let's create an instance of it. So there we go, we have a car. And it has the same functions that the base car class had, even though we didn't rewrite those functions or specifically include them. Like, we can call start engine, we can drive, and then we can stop the engine. So, like we said, car is the parent class in this particular instance, and our child class, the Honda Civic, has all of the properties and methods of its parent class. So we can see that in this way, any attribute that we add to the parent class, we have in the child class. So let's go ahead and go back and take a look at the code. So now, if you want to add anything specific into our Honda Civic class, we can actually go ahead and do that. So we can add something that isn't in our parent class, and even though we're inheriting, we'll get a specific instance of it in our child class. So we're going to add a class level variable. We'll add a few, some of the ones that we had on the instance before. And so now, in addition to having everything from the parent class, we'll also have these specific attributes that we have on our child class. So we can just really quickly take a look and make sure that that's the way that it works. So once again, we can create a Honda Civic. And we have the same methods, but also we have some extra variables that are specific that weren't inherited. So this is the basis of how inheritance works. We specify a parent class, and we basically get everything that the parent class has. So we've seen that inheritance allows you to grab methods or attributes or whatever you want from another class and bring it into a class that you're currently working with. So we have access to all of those things. But what if you want to specifically change one of the things that you've inherited? You might have methods that don't work specific to the use case that you want now that you've inherited a bunch of methods. So what you can do is what we call override the method. One example of this might be you have a car that you have implemented a drive method for, but now you have a specific car, like our Honda that we worked with, and you want it to drive in a different way. But you still want to be able to use the drive method. You want to have the same name. So now you can implement your own drive method that will take precedence over the parent drive method. So even though there's the same function in both classes, the child's class function is the one that's going to get called if you call it. And you can actually do this across chains of inheritance. It doesn't just have to be one parent class and one child class. So overriding allows you to change the behavior in a child class for something that is already defined in the parent class. So let's take a look at doing this with the car that we've started working on. So now, let's go ahead and start overriding some of the methods that are implemented in our parent class. So for instance, say that we want our car to start its engine in a different way. So we define a start engine method on our Honda Civic that is going to override the functionality of the car. So what this will do is when this is called, instead of looking for the method on the parent class, we have it now on our child class. And so we'll be able to call the rest of the methods on the parent class. For instance, stop engine will still work. It'll still actually stop the engine because they're both using the same variables. But now our specific start engine function is going to do something different than what the base car class does. So we can take a look at this really quickly. So when we start the engine, it is now calling the specific start engine function of the Honda Civic class. But when we stop the engine, even though we don't have a specific stop engine defined, it's calling the parent class's stop engine function. So we can use function overloading to write some specific functionality in a class that's more specific, but we can still fall back on the base functionality if we need to. And there's a lot of use cases where you'd want to kind of use a mix of some of your own specific methods, but still use a lot of things that the parent class has. So one thing that might be important that you might have a question about is, what if you want to do both? What if you want to also call the original start engine function and then add in some of your own specific functionality? And there's a way to do that. So let's take a look at how we can grab the functionality of the parent and then do something additional, instead of doing a complete override where we just change the functionality of a particular function call completely. So like we were saying, if you want to preserve the behavior of the original superclasses method, or the parent class as we were calling it, but also add some additional functionality to that, Python has a built-in function called super that allows you to basically refer to the parent class within your subclass, or child class, as we've been calling it. So basically, the way it works is kind of exactly what you see in the example on the right there. In our specific child class, we call super, and then we add our initial functionality. So you call super, which basically gives you a way to access the parent class. Then you call whatever function you want to call. So in this super call, we're calling drive, but that is going to call drive of the parent class and not just our child class functionality. So in this way, when we run this code, if we call drive on our Honda Civic, both that drive and the parent's class's drive will get called. So let's modify our existing example to use a structure like this, so we can call both the parent class's functionality and the child class's functionality within the same function call. So this is our car program that we've written thus far. So what we're going to do is extend the start engine function so that it calls both the parent start engine function and its own start engine function. And this is actually really simple to do in Python. We have a way of accessing our parent class, a function that we call super that's built in. So super is really simple to use inside of the class. In our example in the slides, we looked at kind of an older way that also works for using super, where you pass it the name of the class you want to get a parent for and an object that also gives you a parent class. But inside of our class here, we can just use the super call like this. And from here, we have a way that basically allows us to refer to the parent class. So then we can go ahead and call whatever function we want. In this case, that's start engine. And now, when you call the start engine of our child class, both the parent and subclass will be called. So we're going to change the print text so we can kind of clearly see that these do different things. So what this function will do is use super to get access to the parent class, call its function, so it'll first print out anything that's here, and do anything that the parent class has to do. So actually, we don't need this line anymore. because the parent class will take care of that. And then we can print out whatever additional functionality we want to add in our child class. So this should actually work pretty similarly to how it did before, with just the additional functionality we want in the child class. So we can go ahead and test this now by loading this file into the interactive interpreter. So we create an instance once again. And as you can see, when we started the engine, it called both the parent class's function and the child class. So in addition to executing whatever was in our parent class, we added some additional functionality, and we can see that the variables that we set are still set. So our engine is still started. We can actually drive. It'll work. And everything else works normally. So as you can see, Super allows us to add some additional functionality with inheritance. So we can inherit some methods, we can override those methods if we want to change the functionality completely, and we can use Super to get some of that functionality back and call a method of the parent class and include some functionality from that in our child class's function. One other piece of information that might be helpful to know is that inheritance doesn't just mean that you have to have a single parent in Python. You can have multiple parents and inherit multiple attributes and functions from multiple different classes. So let's take a look at what this actually means. So right now, our Honda Civic only inherits properties and methods from car. But we can create another class and have it inherit some properties from that class as well. So I'm going to create a new class called Blue Car, which is going to extend car, or maybe let's just have it add an additional property that we can see. And let's delete this line from the Honda Civic. So now we have a second class called Blue Car that we can include in our inheritance list here. We can add a comment or a comma and add any additional classes that we want to inherit from, and then place it there, and we'll automatically inherit its properties as well. You can put as many classes as you want in this list of parents, basically. So you just use a comma, you put another class name, and it'll pick up the properties from that class. So now when we create an instance of our Honda again, we'll have the color attribute set to blue, even though we didn't specifically set it, because we're able to inherit properties from multiple classes. So we can look at that really quickly. So we create an object, an instance. As you can see, the color is still blue, even though we removed the specific line in our class telling it to make it blue. We can inherit properties from as many classes as we want. You can put a bunch of classes in your parent class list, and all of the properties and methods will show up in your child class. And you can also chain your inheritance as far as you want. If you were to make another class that adds some additional specific property on top of your Honda Civic, let's say you pull Civic out here and want to create another class that's just a Civic, and you can inherit from Honda, all of the properties will be added. So we can do something similar. So we can, as you can see here, you can chain the inheritance as far as you want. You can have as many children from an individual parent as you might want. And there's a lot of applications of this. If you want to describe more specific use cases like we're seeing here, we're narrowing it down to a general class of vehicles, starting from a general class of vehicles down to a specific color, down to a specific model, and we're adding more and more information with the classes. And you can use this to kind of specialize certain types of information so that you can know what it is inside your program when you're representing it. Because certain more specific types might carry additional information or do something a little more specific. So we can go ahead and instantiate this class and see that it has the appropriate model and all of the right functions that we've defined. So it has the right model and all of the right functions. It's using our same function from the original Honda that calls both the parent class and the child class, and then it has the rest of the functions from car. So classes can be really helpful for thinking about certain types of information we might want to store in our program. We can use the methods and attributes to kind of represent different things about our data, both its actions and properties, and we can use inheritance to represent more and more specific types without having to rewrite all of the information we store in our more basic classes, like we saw in our examples. So programming with objects is going to become really important as we start looking at some of the more advanced features of Python, because all of them, when we start using them, will use objects and classes in some way. So that's it for this lesson.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.